Hey everybody, Daniel here from Basement Tech. I know you haven't heard from me in a while. Things have been kind of busy down here in the basement makerspace. Most notably, you might remember I made that PCB, that printed circuit board, for use on the CNC Router monitoring project. I've made a lot of progress on that project, and that's what I want to show you in this video. Before we dive in, let me remind you what this project is all about. Consider it sort of a smart accessory to the CNC router controller. It measures things like the temperature of the heat sinks in the device. It measures the temperature of the air in the case, which is just interesting. It sums up all of the motor currents and measures that. And it also can measure other digital signals like whether an e-stop is pressed or not. It then takes that data and does several things with it. There are some multicolored LEDs that are local to the box that can be used to indicate, say, a high current versus a low current, maybe red versus green. It also sends that data over a network connection to another computer, which can present over the internet interesting displays of that data like graphs or numerical output. That same data can be used to generate alarms, and as I said, it's all internet accessible. Here's an example of the kind of graph that we can get out of that internet accessible computer I was mentioning. So that's what it's all about, a device to measure the health of the CNC router controller and present it across the internet remotely from essentially anywhere on the globe. Well, here is all that progress in all of its glory. Three major components. You see right in the center is that PCB that was the subject of a previous video. Talk about some additions to that here in a couple seconds. On the left is a long strip of NeoPixels that are going to indicate status and other interesting information. And on the right is a 5-volt power supply. Let me zoom in just a bit to that printed circuit board itself and remind you of a few things. The printed circuit board itself houses a bunch of little blue Adafruit modules, and they monitor things like temperature, humidity, and some other things. I'm not going to go into that in detail because that was a subject of a previous video, but I have added a couple interfacing bits that I wanted to talk about. Down here in the lower right is a little board that contains two opto-isolators. For those who aren't familiar, an opto-isolator is a way to provide a digital connection without any physical or electrical connection. On pins 1 and 2 essentially is an LED, and on pins, I think it's 4 and 5, there's a photosensitive transistor. So the only connection between the two is actually the light that is emitted from the LED. That provides something in the range of 3,000 to 5,000 volts of isolation, mostly for isolating the ground and isolating from any noise that might be transmitted between the two. Also contained on that board is the interface resistor for the NeoPixels. I decided to put the high side current monitor, this little INA169 board from Adafruit, out on the shunt itself. So given that I'm going to have wires running from that back to this board, I wanted to provide just a little bit of signal clamping for protection from any nasty things that might happen. So that's just a 3.3 volt Zener diode to protect the A to D, which is sitting right next to it. The resistor in series is just always recommended with a Zener diode. I do still have the programming cable attached. That's this little USB cable hiding over here, and that'll be removed in the final reel. The power will be provided from that little 5-volt power supply, which I have to admit is the cutest little thing I've ever seen. 5 volts, 5 amps. It's going to provide plenty of power for those power-hungry NeoPixels. So zooming back out, let me talk a little bit about the changes in the software. The ESP8266 is programmed using the Arduino IDE. For those of you who have done some programming of Arduino, it feels just the same. I haven't been in this code in quite a while, but I like to leave myself a lot of breadcrumbs and be very obvious with the software at the risk of being overly verbose, so that when I come back in, I don't have to think too hard about where I was when I left off. So for example, right up here at the top, you see that all of the pins that are available on the ESP8266 module that I have from Adafruit are laid out whether I use them or not, and that just reminds me which ones I've used and which ones I haven't. This section here makes the software useful for various configurations and various combinations of all of those little Adafruit elements that you saw on the printed circuit board. These pound defines, if you will, just tell me whether that hardware is present or not and whether this software should try to talk to it. You saw above a couple extra pound defines for the NeoPixels and for the INA 169, which is that high side current monitor. What you see here are those MQTT. Remember, this software sends the data across a network to a data broker where it can be used for all of the things I described earlier in the video. So these are those topics that are used then to access that data once it's sent. Sliding on down, you see a couple other things that I added. Once in a while, my data stream locks up, and I'm not quite sure exactly where it's failing. So I included here, if the Wi-Fi connect fails and or if the MQTT connect fails, that MQTT connect to the data broker fails multiple times, this little module, the ESP8266, will reset itself. That's probably a good guess at why it's failing, and hopefully will make things a bit more robust in a sort of automatic and hands-off way. Again, at the risk of being a little bit too verbose, here is the section which describes the thermistors. I included this little graphic of the schematic diagram so I remember what the hardware looks like when it comes to writing the software. The only thing more painful than looking at somebody else's software perhaps is listening to them dictate it to you. So I'm not going to do that. I'm just going to give you this sort of quick tour here. Let me continue just with a couple more things to note. Here's that high side current monitor software. The goal here is to take the voltage that comes off of the shunt that's actually measuring the current inside of the controller and take that voltage and convert it back to natural units after having passed through that INA 169 board, which has its own gain. So if you take a look at this software, you can see it's doing that. By the way, this software and all of the software I write is available on the Basement-Tech GitHub repository. So feel free to go take a look and download it, and definitely make any suggestions to me via the comments below if you think they are warranted. Here is the formula that actually does the conversion, and again you can see I've been way overly verbose just to remind myself what things look like. If you slide on down, you'll see the things you would expect. There's the code inside of the Arduino, or in this case the ESP8266 loop, that actually executes these functions you see here to acquire the data values and then convert them to natural units and finally publish them via MQTT. Again, I'm not going to go through that in too much detail, but you can kind of see that. Finally, let me just jump to this NeoPixel section here. NeoPixels are a really brilliant little device. Inside each of the little so-called pixels is a red, green, and blue LED. And by turning them on at different levels, you can get any color of the rainbow. So we can use that, for example, to play out the current values in real time, where a low current, which some might consider better or more healthy, is green, and a high current, which maybe indicates stress for the machine, would be red. And that's exactly what I did here. And here's that little table of R, G, and B values that play out those various colors. I'm able to get about 100 millisecond update rate on those NeoPixels, and it looks pretty cool. So maybe I'll just end with a quick demo of what that looks like. And as I said, if you like this kind of video, definitely press the thumbs up button. If you want to see more of these as soon as they come out, subscribe, and absolutely please leave your comments below with any questions or suggestions. I definitely value that kind of input. So let me just show you a little demo without any talking, and you'll get the idea.